and created the
Okay.
CI/CD pipeline with the automation. Only thing I didn't test is webhook one. Because of the URL change, I unexpectedly deleted my Jenkins server instead of the stopping, so I have to again recreate everything.
Okay, that's fine. That will be helpful to do the hands-on, not a problem. Doing it again will be very much helpful. So no problem. So yeah, Veera has completed, Vijay have completed, they have messaged in the chat. Okay, not bad. How about other people? You can
Preethi, I
share
have
your
one.
experience. How is hands-on going?
Yeah.
What are the blockers? How difficulty you found? How difficult it is doing the hands-on? Have you found any challenges during the hands-on, Karthik?
Yeah,
Uh,
a few challenges. So one thing was, I think it was more of like manual errors, meaning like copying the wrong Git URL, and then when I was trying to do that CI/CD pipeline, some of the dependencies, right, we have to install on the slave server. So those small things, but I was able to sort them out by myself.
Okay. Okay. And were the hands-on documents in the drive, everything helpful with all the details or anything missing?
Yeah, I was about to check with you on that. I think we might need to add few additional steps, probably about maybe for the other slave.
Okay. Okay. You mean for SH agent slave?
Yeah, I mean the pipeline and also the pipeline one, right? So the pipeline you only had it just one URL where how you can do that. But I think if we have little more steps, that would be really helpful. I think maybe in going forward.
Sure. Sure. We'll look into that drive documentation. Anything else from anyone?
This is the conclusion of CI part.
Huh?
Is this the conclusion of CI part?
CI part. CI part. Yeah. Also, we'll make the CI part also better. Completed means it's not completed, but we have done with whatever knowledge we have. Okay, as we go by, we'll be introducing many other tools and make the CI part also much more better.
Okay.
But yeah, to whatever extent we have learned, yes, the CI part is done.
Okay.
Okay.
Hi, Preethi.
Yeah, hi.
Actually, I'm getting this error. I was sent you on chat. After running that copy command
Hmm.
while doing the SSH, I'm getting this error. On the first time
Permission
when I
denied.
tried, it was successfully done.
Hmm.
But for the second and third time, I deleted the instances and tried again, getting this error.
Have you changed the permissions on that file? Like it should be having
Yeah,
only the
I checked on Google as well. They are saying you need to change the permissions. I did the same, but it's still the same error I'm getting.
then you have to maybe something wrong with the PEM file itself, like the IDRSA file. So can you recopy and check once again?
Okay, do we have any alternate option to copy the pen file?
Mm.
Because with that SSH hyphen copy hyphen ID, that command I tried, it's showing me the same error.
It should be working fine as such copy ID. Like what I'm saying is, are you doing with the right user? You should be doing with the
Yeah,
user
yeah.
and
User one,
mm,
correct.
mm. Next time when you're doing, share the screenshot. Let me check. Okay.
Okay, at the end of the session, I'll share the screen, no problem. Sure.
Sure, you can. Yeah.
Yeah. Yeah.
All right then. So today let's begin with the Docker as a containerization tool. We will learn in and out of Docker. This is very, very important. Okay. Docker is a basic for all the containerization concepts, all the container-centric environments. Like I know people, like I see people working directly on Kubernetes without having the concepts on Docker. Okay, which is not great. Okay, like you should be having thorough, good fundamentals of Docker before you proceed to any container and centric environment. So learn this properly, thoroughly, and I would try to deliver my best. So you try to grab the best content. Okay, like follow thoroughly. So let's talk about Docker. Before talking about Docker, First, let's talk about like a scenario which led to Docker environments. Hmm. Let's talk about a simple scenario. Let's say there is a company called Z and it has developed some application called A, okay, some gaming app, let's say. And there were so many clients who are interested to buy this app. Like we have client 1, client 2, client 3, and so on. Okay, there were so many clients. Client 1 is interested to use this app, but he is having a Windows environment with Java 8 and no Tomcat. Client 2 has got Ubuntu 16, okay, with the Java 11 and Tomcat 9. Okay, and client 3 is having um, like Ubuntu, whatever, some, or else let's say he is having CentOS version and he is having Java 8 and let's say no Tomcat. Some like each person, each client or each individual will be having a different set of environments, right? And this gaming app will be working for Ubuntu 16, Java 11, and Tomcat 9. So that's a prerequisite for this app, like Ubuntu 16, Java 11, Tomcat 9. These are the, kindly ignore the typos. This marker is not handy. Okay, so yeah, that's a requirement of the app, and these are the different clients. So how to provide them with the app? For client 2, I can just provide the app very easily, right? How about the client 1 and client 3? Can we provide them with our app? Or is it that you provide your application only for the users like who have the supported environment? If that is the case, business doesn't work, right? You should be able to provide the application to the maximum number of users, irrespective of their platform. It's not that they don't want to change it, isn't it? Just because of our app, they don't want to change their environment. Some of them may don't know how to change their environment. So many challenges. Also, let's say you provide online support, you go to their environment, set up the environment, go to their place on site and you set up the environment. But after some couple of days, it might be again going wrong, right? Again, you need to provide continuous support, which is not feasible. Earlier, we used to do that as well, right? But now, how to handle this client 1 and client 3 as well without losing them? Any solutions to this problem statement? Forget about Docker. Without Docker also there are solutions. I want solutions without Docker. Like what are the solutions to this problem statement? How can we handle this client 1 and client 3 without losing them?
Maybe
We
you need
keep
to
versions of it, different versions.
Different versions of what?
we
Okay.
have to we need to create different client and node model, right? And you need to install manually everything.
That's what is the challenge, right?
Yeah.
Any other problem, any other solution? We have that problem, going and manually setting up will not work. After 6 months or after 2 days, if it got corrupted again, you have to go and provide the on-site support. So any other solution to this problem? How can we handle these clients?
Docker image by creating the dependencies.
Forget about Docker. Any other solutions? I'm talking about leave Docker.
Have to,
Apart from
you
Docker
have,
also there are solutions. What are
without
those?
Docker, you have to wrap this one like a,
Terraform.
you have to wrap this
Package.
gaming app like a package so that it can install, it can support anything. Nowadays, there are a lot of softwares we are downloading. So it's some softwares it's compatible with on any OS, any type of, you
It's a
should make it
bundle.
universal compatible package. So
See, the solution to this problem is virtual machines, right? Do you know virtual machines?
Mhm.
That was the solution, right? You create a virtual machine with Ubuntu 16, Java 11, Tomcat 9, put the gaming app, share the virtual machine, right? That's how this problem can be solved, and that's what we are doing currently, isn't it?
Yes.
You get it now? Yeah,
Yeah.
virtual machine is a solution to the problem. You create a virtual machine, share the virtual machine with client 1 and client 3. They don't need to change that Windows or Java 8. On that Windows machine, they can run the VM with all your dependencies. That's a one solution to this problem. Am I correct? Agree with this, everyone?
Yeah.
Understood what a virtual machine is? We discussed in the Linux sessions a little bit, but yeah. Yeah. So the solution to this, one of the solutions to this problem is virtual machine. Create a virtual machine and share the virtual machine so they don't need to change their core operating system or anything, and they can just use this VM, right? That's a one solution to this problem statement. Yeah, that is being used till date. Virtual machines are the ones, even for our DevOps also. Let's say I'm having some Windows laptop or Mac laptop. I want to learn DevOps. I need DevOps environment. So I'm again using virtual machine from AWS. EC2 instance is nothing but a virtual machine running on AWS data center, like Amazon Web Services data center. I'm using VM, which is running on someone else's data center. The reasons, benefits we discussed. Instead of you managing your own VM on your laptop, where you have to allocate some resources to your virtual machine, we were using virtual machine from AWS. That's how we were handling this situation. Same is the case. Let's say I want to work with a gaming app, but it needs some Windows 7 or older version of Windows. I'm having Mac OS. On that, I'll run a virtual machine, right? Or else I'll use virtual machine of AWS. Same is the case here. The company can create a virtual machine, share it with others, whoever don't have the supported environment, and they can run the gaming app on this VM. That's one of the solutions to this problem statement. Any questions here? Understood everyone what a VM is? And this can also be solved with another solution called container. Like you can also have some containers, right? You can start a container like which is again like a VM. See, I'm just saying for your understanding, like a VM. Container is completely different. What are those differences we'll discuss. But let me tell you, container could be another solution to the same problem statement. Like you create a VM, you create a container and they can use it. Both are similar, but which have a lot many differences, which we are going to analyze today. But here you have to understand both uses the concept of virtualization. Both of them uses the same concept of virtualization. Right? Both uses the same concept. Then you may be having a question, if both uses the concept of virtualization, how different they are. Yes, both uses the concept of virtualization, but in VMs, virtualization is done at the hardware level, right? Whereas in containers, virtualization is done at the OS level. What does it mean? These statements will be justified when we talk about their architectural differences. Now we are going to deep dive into the architecture of both. You will justify this state, but just remember in VMs, virtualization is done at the hardware, whereas in containers, virtualization is done at the OS level. And this virtualization done at the OS level is called containerization. Means containerization is not replacing virtualization. It's a next step to virtualization. That's all. It's a next step to virtualization. It's not replacing it. Virtualization is the basic core concept. Containerization is the next level to it. And the tools which provide this kind of containerization is called Docker. Docker is a tool or a software which provides us with a containerized environment. In simple, let's say you want to run a container. What is container and all we'll discuss, okay? Let's say you want to run a container or create a container. Do anything with the containers, you need to have Docker installed and Docker running. That's called Docker daemon or Docker engine, whatever you call it. Docker should be installed and Docker running. Docker is one of the containerization tools, or else a tool which can provide you containerized platforms. There are other tools like Docker. You have Rocket, you have OCI, you have LXC, other containerized tools were there, Creo. But Docker is very famous and very widely used when compared with anything else. Rocket, sorry, typo. Rocket. Okay. So Docker is very widely used when compared with anything else. I can say 98% of the share is Docker. So you can imagine how huge or how famous it is than any other containerized tools. Okay. Now you may be having a question. When you say both solves the problem, same problem, then what is the difference? Which one to use when to use Docker, when to use when to use VM, when to use Docker container? Like what is meant by this virtualization to the hardware? What is meant by virtualization to the OS level, correct? Now let's deep dive into their architecture to understand the exact differences. Can we proceed? Good to go?
Yeah.
Let us now get into their architectural differences. Hmm. I believe you all can see the screen. Yeah.
Yeah.
Uh, yeah. So let's talk about VMs first. Okay, if you see, yeah, this is my infrastructure. Let's say it may be your laptop, or if you are talking about EC2 instances, it might be the data center, cloud, whatever it is. So this is my hardware. On my hardware, I may have some software. Let's say this is my Mac or your Windows, whatever it is. And on that, I want to run VMs means you need a hypervisor. We have discussed this in the Linux session. But yeah, you can recollect the things, or anyway, I'm repeating this like a refresher. If anyone remember, you can let me know what is a hypervisor. What is a hypervisor software?
It's an integration between the application and the OS, hardware and the OS.
Virtualize.
It virtualizes the hardware.
Hypervisor is a software, right? Hypervisor is nothing but a software with which you can um, one sec. Hypervisor is a software with which you can launch the VMs, with which you can create the VMs. You can do anything with this hypervisor, right? Like examples are Oracle VirtualBox, VMware, VM Workstation. Those are all examples of hypervisor. So we'll have some hypervisor. Above that, you can start some VMs. See, these are the VMs. Okay, these are the VMs like virtual machine 1, 2, 3. Okay, let's say I'm launching 3 VMs. Virtual machine is nothing but again, it's like a normal machine which will have its own operating system. That is called guest operating system. It is having its own operating system. The binaries and libraries, like the dependencies, like we need, see, let's say this app 3 is nothing but the gaming app we were talking about some time back. Okay, this is the gaming app called A. Okay, and it needs Java, Tomcat, and so on, right? So these are the binaries and libraries of those. So yeah, yes. Okay, so it will have the application and the binaries dependencies and its own operating system. And because every virtual machine is having its own operating system, it just works like a normal machine. It can shut down, it can boot, it just works like a normal machine. And remember, all the resources required for this will be allocated from this host only. Okay. Um, Yeah. From this host, we'll have allocate all the resources like memory, CPU. Let's suppose we have allocated 10 GB for it. Okay. Let's say we allocated 10 GB for one VM. Out of this 10 GB, majority of the resources, like let's say 7 GB may be consumed by the OS, remaining 3 GB for the app and the um, binaries and libraries. Because operating system is huge. Again, let's say 15 GB for the second one, out of which like maybe 10 GB by this operating system. It depends, of course, which operating system. But yeah, if you notice, majority of the resources were being consumed by the operating system itself, because it's having its own operating system means obviously it's huge. It will consume many resources, majority of the resources. And if you want, yeah, majority of the resources are consumed by the OS. And yeah, it's because they are huge, they are slow. They take some time to start, reboot, and so on. And they are heavy as they consume a lot of resources. They are quite heavy and they are slow. And I'm running 3 VMs. Let's say I have only 50 GB here. Or my main operating system has got 50 GB. 10 here, 15, 25, and 35. Only 15 GB left. Can I run another VM which will consume 20 GB here?
No.
Even I can't run another 10 GB also because certain things needed for its own process of my main operating system. I can't put 10 GB also. Means how many VMs depends on the resources available. And if you put too many VMs, it may degrade the performance of your system. They may get just hanged out. They may become very slow and so on. These are all the challenges we have. Correct? But yeah, this is how it's working. And guest operating system can be any OS. Let's say my host is Mac or Windows. Irrespective of it, your VM can be Ubuntu or Linux or another version of Windows. It could be anything because it's having its own operating system. It just can run irrespective of the host operating system. Am I correct? And
Yeah.
also, you might have noticed that to run these VMs, your hardware should support. I don't know how many of you have noticed. For these VMs to work, you should go to BIOS and enable something called virtualization technology. By default, all the latest laptops, this is enabled. If not, you have to do it. Have anyone noticed it or have any idea? You have to enable this virtualization in the BIOS, in the input output during the operating system and during the hardware setup. Means basically your hardware should support this kind of virtualization. Right? That's a point you have to remember. This virtualization is happening at the hardware. Your hardware should support it, which is enabled by default. Okay, this is one thing. See, this is, remember, if you are running VMs on your laptop, it's not that if you are connecting to some EC2 instance, that's fine. That's not running on your machine. I'm talking about if you are running VMs on your own laptop. You are connecting to EC2 instance means you are not running them on your machine. I believe everyone is clear with that basic part. So, yeah. So this is how it works. Now let's come to containers. When you come to containers, you can very clearly see here. Okay. See, this is container 1. This is container 2. This is container 3. What is the difference when you compare it with VMs? Can you notice any difference here?
There's no OS.
There is no OS. Containers will not have their own operating system. Okay. But they'll have the application, the binaries and libraries. It just works like a normal machine. It doesn't have any operating system. Then how can it work like a normal machine? See, let's say this is my laptop. I want to run the Docker. Remember, Docker is initially natively developed for Linux. But now you have Docker for Windows also. From Windows 10 and above, you have Docker, but still it's native for Linux machines. So yeah, on my Mac also I can have Docker. Sorry, this is my software, I mean an operating system. If I want to have container, I have installed Docker and started Docker. Docker is running. Now I have containers which doesn't have operating system. This part is missing. Correct? This operating system is missing in containers. But then how can they work? How can they run? They can work because they will use the operating system of the host. They'll share the kernel of the host. That's all. Okay. All right, fine. Because they don't have their own operating system, they don't consume more resources. Obviously, they are light. Because they are light, they work very faster. They can be created on the fly. They can be destroyed on the fly. They consume very less resources, right? See, only 3 GB is enough. You don't need to spend on the OS. Obviously, there is a lot of savage on the resources. So whenever there's a resource, limitation on the resources, or else when there is a constraint on the resource utilization, you can go for containers. Container, literally, as the name says, what is a container? A holder, a bowl kind of, right? So literally container is nothing but which will contain your app, that particular gaming app, and just the dependencies, that's all. Nothing else, nothing more. Just Java, Tomcat, nothing else. Very light, right? Your
Yeah.
application and the dependencies, that's it. A container is like a package which will have your application along with its dependencies. which can be created on the fly, which can be destroyed on the fly. They consume a lot, very less resources. Instead of running 3 VMs, you may run 10 containers also. Of course, exact number depends. Even containers consume some resources, but they consume dynamically. You don't need to assign the resources beforehand like you do for VMs. For VMs, you have to allocate the resources. How many of you know this? Like, okay, let me tell
Yeah.
you. Whenever you create a VM, you have to allocate, okay, 20 GB for it, 30, you have to do it. But you don't need to do it for containers. They consume the resources dynamically depending on the requirement again, from the host, but very less. So they can be created on the fly, very faster, very quick, lightweight. That's what we need, right? So we are going with containers. Remember, to run these containers, you don't need to enable this virtualization in the hardware. Here, virtualization is happening at the OS level. This is what I'm talking some time back. Virtualization happening at the OS level is called containerization. To facilitate this kind of containerization, you need to install Docker and create those Docker containers, or simply containers, whatever you call it. Lot of savage on the resources, right? And they can be created very quick, very faster. They can be destroyed the same way. You don't need a separate team to maintain. But if you start VMs, you need a separate team to manage the VMs, correct? All of that not required in the case of containers. Are we good? Yeah. Then I have a question. Can I ask you, or do you have any questions? I believe you should
Like,
have a question.
what is triggering, madam, for this really for this game in Docker? What really triggering so that our application will get the resources that it needed?
I did not get your question, Vijay. What is triggering the... Oh,
Uh,
you are talking about size of the container?
no, madam.
Asking about the resources that required for to run that application, how we can configure it in the maybe
Is that your question, Vijay?
Like in Docker concept, you said here in virtualization, virtual machine concept, you said that it will use only some of the resources of the main host.
Mm.
Like you in Docker concept, you said like it will automatically
Mm.
take those resources.
Mm.
My question is,
Okay.
will
So
really
his question is how these are deciding to take the resources on the fly,
Is that your,
dynamically, how they take the resources automatically.
is that your question, Vijay?
yes, madam.
Depending on the size, let's say you deploy address book application, how much it needs, depending on it, the container will expand the resource. Of course, again, let's say your address book application needs 2 GB. Your container will be consuming 2 GB from the host. Let's say you deployed some other address book, some other database you deployed. So your database needs 5 GB. Accordingly, it will automatically can know the requirement, and it will consume from the main operating system on which it is running.
I think
Dynamically,
two.
in the sense, it will consume from the host automatically.
So, Preeti, so is that that particular settings would be in the part of Docker engine that okay, we need to set it?
You don't need to set it anything. Dynamically consumes is the default behavior of container.
Okay. Got it. So
They will
if this is the default default behavior, so what if we have exhausted the the memory or the CPUs which we have it in the hardware? If that is the case, how do we limit
they
that?
will dynamically consume the resources, but if you want to set the limits, you can. There are CPU memory flags when you run containers. Let's say it will dynamically consume the resource, but let's say you don't want to consume all the resources, you want to set a limit. You can do that. That is when you run containers, but
No,
default...
no. What I'm saying is here, see, I have a 10 CPU, 10 100 CPU. So if I have assigned it, I'm running the Docker engine and I'm running the containers. So if imagine I have exhausted 90 or the 100% of the containers, the CPU. So then in that case, what happens?
Containers will fail to run. If they don't have enough resources, containers will fail to run. Simple. So that's a default behavior, Vijay. Later on, if you want, you can set the limits as well. But if they don't have enough resources, like anything else, containers will fail to run. Okay.
Okay. Okay.
So yeah, this is what is happening. Now I have a question for you. Let's suppose, okay, let me take here. My operating system is Windows. Okay. Can I run a Linux container, let's say a CentOS Linux container? Or can I run, let's say, C2, I want to have another one like from Ubuntu distribution of Linux. C3, I want to run some other Windows version, some other version of Windows Server. Were all these three containers possible on my Windows operating system if my host is Windows? C1, C2, C3, which of them are possible?
Yes, ma'am, it's possible.
You can
Possible.
run.
No. How is this possible unless we have some agent or something installed?
Why not possible? Why
How
possible?
is that? Because
All the container
yeah.
images.
Please, one by one, please. Some of you answered possible. So tell me how it is possible. Or some of you answered not possible. Why? Why not possible? Come on, one by one, please. Come on. Yes, Suresh, please go ahead, and
Oh
then
no,
Indra will go
I
ahead.
think it is possible. The thing is that when we are launching the application and it will be running on the host operating system,
Hmm.
right? So I think it is possible. Whatever the applications, it is picking it from the host operating system, and it will work as usual normally.
Okay, Mahendra, can you go ahead with your answer?
Yeah, ma'am, it's possible because we can pull the images of the different type of virtual machines. So it could be the CentOS, it could be the Ubuntu, it could be a window environment. So it's a
All right. Thank you. And anyone else want
It
to
would be
answer?
possible because the we are just looking at the host operating system, right? So the guest operating system will not come into picture here. So maybe it is possible.
Okay, any more answers? Thank you all for answering. Any more answers? Anyone want to respond?
You said no, madam. It's a container which will have its own operating system. Uh,
That's where your answer is. Container will not have its own operating system.
yeah.
Containers are not having its own operating system. So this is not possible. This is not possible. CentOS container not possible. Ubuntu container not possible. Only this is possible. Windows. See, I told you containers will not have their own operating system. They'll share the operating system of those. They'll share the kernel of those. Can a Linux container share the kernel of Windows? When they are sharing the same kernel, how can a Linux container share the kernel of Windows? So point to note here is if your operating system is Windows, let's say my laptop is Windows 10, I can run only Windows containers. Different distributions are fine, but I can run, let's say, Windows something else like Windows 10. Other versions of Windows are fine, but I can't run Linux. Let's suppose my host is I have a Linux laptop. Okay, it's a Ubuntu laptop. Yes, then I can run Ubuntu container. Sorry, any Linux containers. Ubuntu, CentOS, Red Hat, anything is fine. Distribution should be same because they share the same kernel. Make a note of it. This is very, very important because container don't have their own operating system. They share the kernel of the host. So if depending on your host operating system, you can run only those containers. Different distributions, different versions are fine, but the base should be same. Whereas in VMs, that's possible because VM has their own operating system. Guest operating system sits above the host operating system. Irrespective of the host, you can run anything here. That's possible. But here it's not possible. But then listen carefully before you question. Okay, listen please. Let's suppose this is my Windows. Okay, this is my Windows laptop. Any version is fine. You don't worry about versions. On this, I can run only Windows containers. any number of windows, any different versions. These are all Windows containers only. Let's say Windows containers only. Let's say I want to run Linux containers. How do you do that? You have to run a VM on your Windows laptop, some Linux VM. By the way, Docker should be installed here so that you can run Windows containers. Now, on this Linux VM, I will install Docker. Then I will run some containers. Or which type of containers I can run on this VM?
Linux.
Only Linux containers. Because this is the host for them. Wherever their host is nothing but Docker host is nothing but machine where containers are running. So this becomes their Docker host. Linux Docker host means you can run Linux containers only. But for these three, Docker host is this one, they can run only Windows containers. These three are Windows because this is their Docker host. These three are Linux because this is their Docker host. Is that making sense now?
Well,
Okay.
Clear now?
Again, this line.
Don't get confused. It might be your laptop, it might be your Linux VM, virtual machine, it might be an EC2 instance. If you are running Docker containers, see where you are running. Okay, I'm running the Docker containers on EC2 Amazon Linux 2 instance. So that is their host. Their host is Linux. I can run only Linux containers. Let's say I take Mac. Mac is also like Linux only. Docker consider it as Linux. So on my laptop, I can run Linux containers only. I want to run Windows containers means I should get some Windows EC2 instance. EC2 provides Windows also. I believe you all know that. So you create a Windows instance, then you run Windows there. Or else take another laptop which has Windows, then run Windows there, Windows containers there. Are we clear?
Yes.
So this is the point you should make a note of. I'll also show you as we go by, I'll show you this OS compatibility. I'll demonstrate it in the lab.
I
But
think we can use WSL platform, no? WSL platform for the Linux environment in the Docker container.
Repeat please. In the beginning, your voice is not clear. First part.
I think we can use WSL platform for the using Linux
See,
container.
WSL, a platform, irrespective, again, it's a Linux, right? The whole
Yeah.
point is same. Either it is WSL or whatever it is. Whole point is you should have Linux environment.
Yeah, yeah. Okay.
That's all is the point. All right. So, yeah, I believe, yeah, that is about this architecture. Now I know, now I believe you know what is containerization, what is virtualization. And again, I'm telling you, virtualization still has their role. Okay, containers are next step to it. You run containers as packages. Where do you run the containers? Again, your containers should be running on some physical servers or VMs and so on. Right? So containers are next step to virtual machines. It's not replacing it. And another thing is, yeah, you might be having a question when I said operating system compatibility. I told, can I run Ubuntu container? Can I run CentOS container? But sometime back, I told you containers don't have operating system. How can you say Ubuntu container, CentOS container? Anyone doesn't have this question? Anyone got this question or not? Yeah,
so
I told some time back it doesn't have OS. Yes, please.
I think it is using the host operating
host
system
of
terminal, right?
Host operating system, I told it's a laptop, right? Like, let's say, okay, it's a Windows. But how can you say it's a Windows container, Ubuntu container, CentOS container, or Windows container? First of all, it doesn't have any operating system. Then how come you say a Windows container cannot share the kernel of Windows? Yeah, how can you say Windows container or Linux container? When we talk about there's no OS, how can you call it as Ubuntu container, first of all? See, it's because it doesn't have OS means it will have OS, but a minimal OS, only the binaries and libraries of the, like a minimal operating system. Okay, it doesn't have a full-fledged operating system so that it can work on its own. It will share the kernel of main host, but it will have the binaries and libraries. Good, just make a note of this as well. That is one thing. Another thing is always the best practice is one application per container or one service per container is the best practice. You may put too many, like let's say your application is Java, PHP, database. You can put all of them in one container, but the best practice is Java on one container, PHP on one container, DB on another container, like 3 containers for your application. That's a best practice. How it works, why each one on a separate container, all of that coming up. Okay, we will learn. Just those are few pointers I want to mention here. Another thing is, one more thing. Till now, developers are giving you the var file. You are taking it. You are struggling with underlying dependencies. In the lab setup, we have done that. You all remember? Like you have to install Java 8 for Maven package, Java 11 for Jenkins. So many Javas you have to maintain. Suppose if they got messed up, it's not working. Have you faced the scenario? In our lab also we did, right?
Yes, ma'am.
Yes.
Yeah. You have to work on those underlying dependencies where a lot of inputs from developers are needed. This is the traditional approach. In our first demo class also, I told you, developers, the way developers handing over in the application and how they hand over the application changed. Earlier, they used to share this var file to the developers. Developers have to work on the underlying dependencies like which version of Java, all of that. They have to prepare the servers, put this var file, correct? They have to deploy this var file. They have to install Java, Tomcat, whatever this var file needs, correct?
Yeah.
Yeah, they have to work on these underlying dependencies. Somehow, okay, they install an application. After some time, this Java might have upgraded by mistake or someone have done it. Again, it will not work. They have to work on these underlying challenges. But now, how they were handing over the application, developers will hand over this container, not directly that var file. They will containerize it and give it to DevOps people. So DevOps people need not work on which software should be there, which version of it should be there and all. Means application is coming along with the dependencies. Got me, everyone? Yeah. Application is coming along with the dependencies. They'll share the containers. That's why even you are a developer, you still want to be a developer. You don't want to learn DevOps. You don't want to become a DevOps person. Still, because you have to, the way you share, the way the applications are packed completely changed. So you should know containers. Docker, everyone should know. Understood? They'll share the container. As a DevOps person, you don't need to go to server, install Java, check if Java is there, check if Java is upgraded, downgrade. You just run the container. It works seamlessly in any environment. Means it overcomes, it eradicates whatever environmental issues we have. We faced these issues in our lab also. Because we did MVN compile on the slave machine, we did not get the issue. You try to run MVN package on the slave. MVN package definitely needs Java 8. You have to struggle with setting up that Java. Have you all faced this issue or not? I want to hear from you. In our
Yes.
pipeline, in our lab itself, we faced this issue. True?
Yes, ma'am.
Yes.
Yeah.
Yeah.
So, yeah, I want to show you that practical scenario problems. That's why I asked you to do that way. But that's not the right way. After packaging, they should containerize it. That's why we paused our pipeline there. We know how to deploy, but still we will deploy it as a container because to solve such problems. So yeah, deployments can become faster because developers will share you container. You don't need to work on those underlying issues, right? That's how the way of development, the way of deployment completely changed, which revolutionized. I mean, this Docker brought complete revolution in the area of deployments. Anyway, I believe you understood whatever we discussed on this architectural part. Good to go.
Yes.
I would like to proceed to this page now. Yeah. Docker is a tool. Docker is a tool which provides containerization platform and help in running containers. It helps developers, listen this carefully, it helps developers to pack the code along with its dependencies and ship it as a package. Means they are not just throwing that WAR file. They have to put the WAR file along with the WAR file needs and share that container with other teams. Okay, so it ensures our application works seamlessly in any environment. The same container, be it a test or prod, whatever it is, it works seamlessly, right? You don't need to install Java on test, dev, prod, no more. That's how it brought a lot of change, and this architectural we have discussed, and the use cases. If you want to run multiple applications, like I said, your application has many services. If you just want to run all of them together, you put on a VM. Let's say, okay, same address book, you want to run 100 instances. Better you go for 100 address book containers than running 100 address book VMs, correct? Means 100 VMs where address book is running. So, see, we will see all of these things practically. Just get some overview idea, okay? You will get all this blurriness erased when we start the hands-on. And VMs are platform independent, like because it's having its own operating system, it's irrespective of the host operating system. But containers are platform dependent. VMs consume a lot of resources. Containers are limited resources. You can, if you have limited resources, if you have limitations, you can go for containers. And for VMs, you don't need root user privileges, but again, for containers, you need to have root privileges to run them. Development. Yeah, you build it and you can run anywhere. They're bothered about building the containers with the code libraries. That's how developers are using it. And deployments like DevOps team, they'll run the containers. They'll check the containers, access, networks, and all. See, environmental issue. This is what I'm talking about. Code might be working in developer's machine. They give that WAR file to test or other environments. It will not work there because the developers might be using another version of Java, whereas these people might be using something else. You might have seen this in real practice also. Application works in certain environments, but not in prod. Particularly if it is not working in prod, you can imagine the chaos and the challenges. You have to sit, troubleshoot, identify the issue, fix it, right? But now all of this overcome with the Docker. See, an application works in developer's laptop, but not in testing and other environments. This is because of the compatibility issues. All of this can be overcome. Are we clear with this problem? Then, yeah, now that we got an idea, we can talk about containers. Docker components in depth. Good to go? Or any questions from anyone?
Madam, only one single application can be run in a single virtual machine, but can we run multiple in single virtual machine?
In virtual machine, you can run any. In container also, you can run any. But the best practice is in container, one application per container is the best practice. You can run many in container also.
Okay.
Okay.
So to decrease the load, we are sharing that in container.
Why we are doing it, we will discuss. Okay, but that's the best thing. Why you have to do it, why not, we will discuss. That comes under microservice application, microservice architecture. Okay.
Okay.
We will talk on that. So now till now we were talking about container, right? But just understand, how do you get a container? You get a container from something called Docker image. Docker image is something from where you get a Docker container. Means container is a running instance of an image. Till now we were talking about container, right? Just a second. Okay, so from Docker image, you get a container. Container is nothing but running instance of your image. It's a running instance of your image. Means, let me tell you, Docker image is a simple static file or read-only file. This is the running instance of it. Okay, And also you can, if you want to compare, you can compare it like whenever you start a virtual machine, you'll have something called .over file or VMX file, right? You run this, you get a virtual machine. Am I correct? I don't know how many of you notice this or have idea, but this is how it is working. You'll have some VMX file, okay? You have to run it so that you get a VM, something like that. Docker image is a file, a small file. Okay, when you run that, that's your machine, that's your container. So that's why container is called running instance. Okay, and Docker image is the actual file. See, see this diagram from Docker image, you can start a container. And how do you share the container? Still now I'm talking about developers will share a container. Actually, they'll share this image. Containers can't be shared. They are the running entities. Okay, you will share that Docker image. Similarly, if you want to share a VM, you will share that VMX file or OVA file, right? So that image, developers will give you the Docker image. How do they give you? There are many ways to share. One way is there is something called, there is a service called Docker registry. This is registry. Docker registry is a service where Docker images can be stored. That's called Docker Hub, is a public registry. So you can store your images here. From there, any teams can pull them and start running them and create a containers. Okay, that is one thing. Again, registers can be public, private, we will talk about it. But yeah, that's a concept. Images will be stored in some place called registries. Registries are the storage place of your images. Okay, fine. There were so many official images already available on Docker Hub. Hundreds of them are available. Like some Ubuntu image, Tomcat image, already Ubuntu with Java. So many are there. You can directly use them. All the standard ones are available. But what if you want to create your own container with your enterprise application, correct? Means you can create your own images. How do you do that? That's where comes something called a Docker file. From Docker file, yes, you can create a Docker image. Either official images or your own image. This is how it's created. Okay. Okay, so from Docker file, you get an image. From image, you get even official images. I told you so many are there. Even they are also created in the same way. But if you want to create your own image, yes, you create your own Docker file. You have to build it. What is meant by that? We'll see. You build it, you get an image. And what is Docker file again? It's a simple text file where you put some Docker instructions to pack your application along with the dependencies. Okay, and then build it, you get your own image. Again, you can store it on registry, share it with others. This is the flow. See, this is the formula one should remember throughout. You should remember this really hard. This is the formula. Means from Docker file, you get an image. From image, you get a container. You build the Docker file, you get an image. You run the Docker image, you get a container. That's a formula you have to remember. And those are all the components. See here, Docker file. From that, you get an image. Images are stored on Docker Hub. Docker files are stored on, Docker file is a text file where they'll be stored. These can be stored on any version control systems like GitHub and so on. That's just a text file. Till now, we have version control dummy files. Now, Docker file can be another file which will version control. Are we good on this page? Any questions? Docker file, Docker image, Docker container, Docker Hub. These are the 4 terms you need to get an idea on this page.
Madam, can you explain me the staging server and production server? What happens after we putting that Docker image in the Docker Hub?
You store this Docker image on Docker Hub. Other teams, like if you want to create staging environment, you may pull that image and run that image. You get a container, which is nothing but your staging container. Means or else container in the staging environment, production environment. Same image you deploy or else different images. Like once images are stored on Hub, you can download from there and start the containers in different environments.
Okay, staging server is physical server.
Container. Staging. Container on staging environment.
Okay.
Containers on production environment.
This production server means where we
Some
use the
physical server, okay, which is
okay.
dedicated for production for end users utilization, a physical server, or it could be VM, whatever it is. It depends on the project and how they design. On that, you will run your containers for production or for staging or pre-prod or for UAT or testing, different environments you will have, right? So from the registry, you can pull the images and run the containers on those servers.
Okay.
Preethi, I have one question. Like the developer has the developer responsibility to create the Docker file and build and provide you as the image, right? Okay.
Docker file will be created by developers. That's one strategy. They'll just create a Docker file. Through the pipeline, you will build from the Docker file. You can create an image and start a container. That's a DevOps thing. Means Docker file is there in the repository along with the source code, it will be placed. You run the pipeline to build it, create an image and deploy it. Through the pipeline, you can do everything.
But we
Initially,
have this DevOps
we
team.
will learn, let me finish, please. We will do everything with the pipeline, but before that we will do all of that manually. We will learn it, then we will automate it with the pipeline. That's how it is. And one more thing is, yeah, this is one strategy. In team, developers will create the Docker file and do it. There are certain projects where developers will not have idea about this Docker file. There'll be separate DevOps team for that project where they will create this Docker file. So everyone should learn creating Docker file. Generally, that's the role of a developer. This Docker file. There might be another Docker files where you just have to create some environments, like you need a CentOS environment, just some environments, DBs installed, that's all, not to deploy your application. Those containers, Docker file, you can create as a DevOps person. Am I making sense?
Yes.
What I'm talking is, this is a Docker file. Let's say this container is which runs your address book application. Then they should be definitely created by developers. But there might be another Docker container, okay, where I need some database running with some Tomcat also there and something like that. Those are anyone, I mean, DevOps people have to create that infrastructure images. Application images, developers can create. But still, if developers have no idea, in some projects, there is a separate team who will help developers create these Docker files. Okay, in whole, DevOps team should concentrate on creating Docker files like this. But yeah, everyone should know creating any type of Docker file. That's good.
But DevOps team should not have that any responsibility to get this underlying files or any libraries, all those stuff, right?
No, they will not. They
Okay.
have to provide that all the information. They can help you create the Docker file. That's all. Not the underlying dependencies. All of that developers should share.
Okay. Thank you.
So that means the Docker image or the Docker file will contain the linking or the pointers to application also.
Correct. It will have a pointing to code, the libraries, dependencies.
So then how can we, how can the public images, like you told, Docker Hub will also contain some images and all. So those, there would be different kinds of Docker images wherein it is respective to application or respective to DB or respective to only the environment, like that.
See, enterprise applications will not be there on Docker Hub, right? Those you will be creating your own. The ones available on Docker Hub are generally like Ubuntu ones with Tomcat or Nginx images, those standard.
Yes, that's what. Like there would be a general kind of images also, and there would be specific to our application or our DB or something like that also.
Correct.
Okay.
Any more queries? So,
It is,
uh,
sorry, yeah. It is like one container per environment. It is how the scale of that. In general, it is
one container,
container
like
communicate.
one instance which runs address book. If you want to scale 10 instances which runs one address book instance.
So each instance has their DB connected as well, right? So it is part of each.
We will talk about it, Veera. Just understand one app per container. How it is, we'll talk about in microservice architecture. Let's not get into that depth now. Just understand this flow. From Docker file, you get an image. Docker files are the ones which you create. Okay, just concentrate on this part. We'll talk about those things. We are going to deploy microservice applications as well.
Is it a best practice to deploy multiple containers in the same VM, in a one VM?
Yes,
It's a real-time.
yes. Yeah, that's how you deploy multiple containers on a particular VM. Rather than
Hi, ma'am.
10 VMs which runs address book, you can run 100 containers on one VM, right? That's a best practice in the how you work in projects.
Ma'am, is it possible so
See,
we can
one
scale up,
second.
scale down?
Give me a second before I proceed. See how many containers you run. How do you run multiple applications on one container, on one VM? We are going to do that. Okay, all of that we'll do hands-on. Don't jump onto the topics which we are going to take up. If you have questions on in this part, ask me. Like I said already, one container per app or how it is, we will discuss with the hands-on. Don't get into that part. How many containers on a VM? Do we run container on a VM? We are not running it anyway. I'll take you through step by step on that, so that all of these questions will be answered automatically. So questions on this part, whichever we discuss, please put them.
Yeah, ma'am, I have a question.
Tell me, please.
Yeah, can we scale up, scale down the container when we required multiple container the same project? So how is it possible?
How meaning? Do you want the command or do you want me to show them?
Yeah, it's like command. So suppose we suppose vertical and horizontal scaled up. I asked.
Docker compose scale the service name. Do you understand with the command now?
Yeah,
We're
something.
going to do that, Mahendra. That's what I'm talking about. How meaning we are going to do the hands-on. We will discuss all those things. You just need the command. It's a Docker run container scale equal to the number. That's a
Okay,
command.
okay, okay. Thank you.
Yeah,
The
when
random command will not help you, right? We did not start the Docker commands. How can I show you how do you scale up? But scaling up possible, all of that possible. We are going to see those. Yes, Vijay?
when in that container you said that it is going to use minimal operating system that we are
Hmm.
going is that we are going to mention that Docker instructions.
Yes. Yes, all of that will be available on those Docker instructions. I told you Docker instructions, right? Those instructions will take care of all of that.
Okay, okay,
How we will see with the hands-on.
okay.
Any questions on this flow? I'm expecting you to understand this one. Docker file, you build it, you get an image. You run the image, you get a container. And images are stored on registry. Like I said, Docker file will have your application binding with the dependencies. All those Docker instructions will be present there. These things, if you have any questions, you ask me. Scaling, all of that we will do. How can I just give a random command like that? It will not be helpful to you.
Yeah, Preethi, one question on this. Like the Docker engine, where comes this Docker engine
Okay.
comes in this place?
Okay, Docker engine should be available on the machine wherever you are running this. Like Docker build you is a command, Docker run is a command. If you want to build containers or if you want to run containers or create Docker images, you need to have Docker. Means let's say I want to create a Docker file and build an image. Where let's say on an EC2 instance, on that EC2 instance, you should have Docker installed. To run any of these Docker commands from any machine, whichever machine you want to run, you should have Docker installed and Docker running.
It's a basic setup on the Docker to enable Docker, correct?
You have to install Docker like any other tool. You have to install Docker, then only you can do any of these things.
Is it Docker specific to that VM, or it is it understands, right? Or it is
Docker specific to?
specific to that instance, like Linux or CentOS, specific to the instance that we are.
Let's say I have my Mac operating system. I have to install Docker there, like I install any other tool, Git. I have to install Docker there.
Suppose on the Mac, right? It's the same Docker. I mean to say different flavors of Dockers to be installed on the instances.
Okay, I'll answer your question in some time. Okay.
Yeah.
Any more questions? See, this is the formula I'm talking about. Docker file, from there you build an image. From image, you have a container. Right? What is inside Docker file? What is inside image? The same formula. When you go into depth, this is how you see them. Okay, we will talk about all of that, but before that, we can install Docker. Okay, I am going to install Docker on the same machine. On the same EC2 instance we have used till now. Okay. Till now, whatever machine you are using, you can just go to that machine and install Docker. Installing Docker is quite simple. Just like you install any Git or Maven and anything else or Jenkins, just install Docker will do. Okay. Let's connect. You can use the same instance where you install Jenkins. So do you have Docker? No, Docker command not found. Let us install it. Why I'm installing it? I want to run some Docker images. That's all. That's it. Once it is installed, systemctl start Docker. That's it. Docker is running. Now you can run any Docker commands. Now it will not tell you Docker command not found, but it's giving a lot of verbose. Those are all different Docker commands we are going to use. First one is Docker images. This will list all the Docker images available on this Docker host. This EC2 instance is nothing but Docker host now, correct? Because that's a machine where Docker is installed and Docker is running. So this should list all the Docker images available. It's listing only the header, but not the images because it's a new Docker host, nothing there. So no Docker images. Then how to run a Docker image, from where I can run, where is Docker Hub, what happens now, how to create containers, all of that we shall take up tomorrow. I believe this answered your question, Veera, how to install Docker. That's all. It's like a software. It will be installed on a machine. Now you can run any containers, any images, anything you can do. We shall start the hands-on tomorrow. Any more questions from anyone? See, there is a lot of content we'll be covering on Docker. Okay, Docker lifecycle, Docker registries, private registries, public registries, pulling, pushing. Okay, Docker container lifecycle, running Docker containers in different modes. Okay. Containerizing our address book application, containerizing a database, containerizing a PHP1, containerizing a microservice application altogether, scaling them, scaling down, scaling up, scaling down, Docker Compose, Docker Swarm, so many things are coming up. Okay. Go through the recording today. Today it's almost the theoretical part, but which is very, very important. We spend a whole session on it. Make sure you're listening it at least once before you join the class tomorrow. Any more queries you can ask me.
Madam, Docker means it's a Docker engine that we are talking about. Both mean the same one.
Correct. Docker means Docker engine, Docker daemon. Yes.
Okay.
I believe when you watch the recording, you will get the questions. If they are to the context, you can note it down. If they're out of context also, okay, note all of your questions. Out of context questions, majority of them will be covered as we go through those topics. After finishing Docker also, if those questions are not answered, you can again put those queries. I would suggest to put the queries to the context. Anything out of context at the end. Now you can ask me anything else you have. If I'm going to cover them or not, I can tell you. Let's follow this so that we will not get deviated and will not divert the tempo of the class. Tell me, please.
Preethi, like, is that like how the memory management on the
How?
Docker is, how the memory management of storage can be, how much size it has? Is there any limitations on the Docker instance running the apps?
They will consume dynamically, okay, but if you want, you can set the limitations using container memory flags. I will show you in the class as we go.
Yeah.
Any more? I think that's all from my end. So watch the recording, okay, and then let's go through this. Let's continue this tomorrow. All right then. Bye everyone. Good day. Thank you all.
Preeti, hello.
Tell me please.
Yeah, regarding that question error I'm getting
Yeah, you
when
can
doing
share
the
your
SSH.
screen if
Yeah,
you want.
yeah, sure.
Karthik H, right?
Yeah, correct.
Yeah, you can share your screen.
Yeah, it's visible, right?
1 second. Yeah, it's visible.
This is I'm getting.
Can you do SH keygen one?
This is keygen, right? Okay.
Right. Enter. Give enter. And why? Override. You want to override. Do SH keygen again. Enter. Yes. Y. Give a Y.
Yeah.
Enter. Enter. Now run it again. Can you go to the AWS console once? Show me that IP of the slave. Okay, go back, please. Have you followed all the steps? Go to that target machine. I mean, go to that slave machine. Can you connect to that?
Yeah. This one.
Sudo su hyphen. Switch to root. Vim etcd conf file. Did you made password enabled here?
Yeah.
etc.
Let's see.
sh config. I think it is sht.
Yeah, SSD config.
Did you make changes here?
On the slave, I haven't done that.
You
On the
have to do
master,
it
I
on
have
the
done.
slave, not on master. Scroll down, please. Okay. Password authentication should be enabled, then only it will ask for you. Scroll down. There. Top.
Okay.
Yes. Remove that and put that comment on the next slide. Save the file. Restart SSH. systemctl restart as well. Now try out copy command. Okay.
Okay, now I got it.
That's
Yeah,
password incorrect.
got it. Yeah.
Now you
I
do
think
sh directly, sh user1. You can copy above one. It was showing, see?
yeah, this one.
Single quote is required.
Single quote is required. That's what you're saying.
Single quote. Okay. Bad permissions. Key file. chmod that file ID RSA. chmod 400 home /home user1 /home
Slash one. Okay.
user1 dot ssh /dot ssh /id RSA id underscore RSA. I think you already logged in. That's a 11 machine. See? 1111.
Yeah, correct. I have.
Have SSH.
Yeah, I got it. Yeah,
All right then.
27 triple.
Yeah.
Yeah, got it. Sure. Thank you, Preethi. Yeah.
All right then. Bye everyone. See you.